Chapter 3 Periodic Table 3.1 Classifications of element. In period are arranged in order of increasing proton number. Example: first element hydrogen with proton number 1, second element helium with proton number 2, third element lithium with proton number 3, and etc. Horizontal row in periodic table is known as a period. The period in periodic table are numbered from 1 to 7. Example period for potassium and end with krypton. How to determine period? Determined by referring the highest principal quantum number in electron configuration. Example configuration of sodium is 1s, 22s, 22p63s1. Highest principal quantum number, or highest occupied energy level is 3. So is located in period 3. Group. Vertical column in periodic table is called a group. The group in the periodic table are numbered from 1 to 18. Example: group 1 contains hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Group. It can be determined by referring to its number of valence electron. Examples: 1s, 22s, 22p63s1. Number of valence electron equals 1. Sodium is an element in group 1. Elements in the same group have the same number of electron. Example: sodium and potassium are both found in group 1, which means that they both have 1 valence electron. A block of the is a set of elements unified by the orbitals their valence electrons, or vacancies, lie in. The block names S, P, D, and F are derived from the spectroscopic notation for the value of an electron's azimuthal quantum number. All the elements in the periodic table can be classified in 4 main blocks according to their valence electrons configuration. These main blocks are S block, group 1 and 2, P block, group 13 to 18, D block, group 3 to 12, and F block, lanthanides and actinides series. S block, group. The filling of valence electrons involve the s orbital. Configuration of the valence electrons is ns1 to ns2. Example: electron configuration of sodium is 1s, 22s, 22p63s1, and electron configuration of calcium is 1s, 22s, 22p63s, 23p64s2. Both have configuration of valence electrons 3s1 and 4s2. P block 13 to 18. The filling of valence electrons involve s and p orbitals. The configuration of valence electrons is ns2np1 to ns2np6. Example: electron configuration of aluminium is 1s, 22s, 22p63s, 23p1, and configuration of valence electrons is 3s, 23p1. Example: electron configuration of tellurium is 1s, 22s, 22p63s, 23p63d10, 4s, 24p6, 4d10, 5s, 25p4, and configuration of valence electrons is 5s, 25p4. Group 3 to 12, also known as a transition elements. The filling of valence electrons involve ns2 and n-1 d orbital. Configuration of valence electron ns2 n-1 d1 to ns2 n-1 d10. Example: electron configuration of vanadium is 1s, 22s, 22p63s, 23p64s, 23d3, and configuration of valence electrons is 4s, 23d3. Involve the elements in the series of lanthanides, lanthanum to lutetium, and actinides, actinium to lawrencium. The filling of valence electrons happen in the subshell of 4f and 5f. Example: electron configuration of lanthanium is xenon electron configuration 6s24f15d1, and filing of valence electrons happen in subshell of 4f. That's all for. Thank you for listening. Don't forget to attempt the formative assessment before this hour ends to secure your attendance in this lecture. Goodbye, guys.